Let us take the new topic, which is Euler's theorem for homogeneous functions. Let us first understand what is a homogeneous function. A function, say z equal to f of xy, is said to be homogeneous of degree n if we can express z as x power n, and then the function remains of y by x. Or you can also say like this: if we can replace x by tx, y by ty, and if we can able to express f of tx ty as t to the power n f of xy, then we can say that this z is a homogeneous function of degree n. Like if we have z equal to, say, suppose x square plus y square over x plus y, then we can write this as, like, if we can take x square outside here, so it is 1 plus y by x square. Here we take x outside, it is 1 plus y by x. And so now here we have x into some function of y by x only. So, or you can write this z as fxy and f of tx ty, as this is t square x square plus t square y square upon tx plus ty, and we have t square outside here, x square plus y square, t outside, x plus y, and so we have t x square plus y square over x plus y, so this is t of f of xy. And so we can say that z is a homogeneous function of degree 1. Now, there is one theorem on the homogeneous function. So that theorem is known as Euler's theorem. Let us take the two variables. It is true for n variables also. So the theorem is like this. If, so z equal to f of xy is a homogeneous function of degree n, then x times del z by del x plus y times del z by del y equal to n times z. We can prove this. it is simple proof, we can consider that as an example also. Now you are given z equal to f of xy is a homogeneous function of degree n. So we can express z, it's by definition like x power n f of y by x. Now take the derivative with respect to x. So here we have two terms. So that is n x power n minus 1 f of y by x plus x power n. This is f dash y by x, and derivative of y by x with respect to x is minus y by x square. And so we have n x power n minus 1 f of y by x minus, this is y, x power n minus 2 f dash y by x. And if you multiply with x, so that is x times del z by del x, so that is n x power n f of y by x minus y x power n minus 1 f dash y by x. So we call it is number 1. Now again, z equal to x power n f of y by x. Differentiate partially with respect to y. So that is x power n, which is constant, f dash y by x, and derivative of y by x is 1 by x, because we are taking derivative with respect to y. So this is equal to x power n minus 1 f dash y by x. And therefore y times del z by del y equal to x power n minus 1 into y f dash y by x. So this is 2. So if we add 1 and 2, x times del z by del x plus y times del z by del y equal to n x power n f of y by x minus x power n minus 1 into y f dash y by x plus x power n minus 1 into y f dash y by x. So these two cancel, remains n x power n f of y by x, but x power n f of y by x is z. X power n f of y by x is nothing but z. So that is the proof. X del z by del x plus y del z by del y equal to nz. So if z is a homogeneous function of degree n, then x del z by del x plus y del z by del y equal to n times z. There is one corollary, like same as z is a homogeneous function, z is a function of x and y, is a homogeneous function of degree n, then x square del square z by del x square plus 2xy del square z del x del y plus y square del square z by del y square equal to n minus 1 into z. Now we can solve some examples. So need to remember this and this one. If z is a homogeneous function of degree n. So let us if z equal to 8x square plus y square into log x minus log y, then find the value of x times del z by del x plus y times del z by del y. Second, x square del square z by del x square plus 2xy del square z del x del y plus y square del square z by del y square. So here z we can say equal to fxy equal to 8x square plus y square into log of x minus log of y. We can write this as 8x square plus y square into log of x by y. Use the property of logarithm. Now let us first check about the homogeneous function. So for that, let f of tx ty. So this is 8 t square x square plus t square y square log tx by ty. So this we can write as t square 8 x square plus y square into log of x by y. And this is f of xy. So this is t square f of xy. Therefore, z equal to f of xy is a homogeneous function of degree 2 because t square 2. So therefore, by Euler's theorem, x times del z by del x plus y times del z by del y equal to n times z. N is 2 here, so it is 2z. And second, x square del square z by del x square plus 2xy del square z del x del y plus y square del square z by del y square equal to n minus 1 into z. So this is 2 into 2 minus 1 into z. So this is 2z. Let us take one more example. if say u equal to x power 4 y power 2 sine inverse y by x, then find the value of x del u by del x plus y del u by del y, and second x square del square u by del x square plus 2xy del square u del x del y plus y square del square u by del y square. So here you can consider equal to f of xy equal to x power 4 y square sine inverse y by x. Now f of tx ty. So this is tx power 4 ty power 2 sine inverse ty by tx. So this is t power 4, t power 2, so that is t power 6, x power 4, y power 2, sine inverse dt cancel, y by x. So this is t power 6 into f of xy. So therefore, u equal to f of xy is a homogeneous function of degree 6 in x and y. And therefore, by Euler's theorem, x del u by del x plus y del u by del y equal to 6 times u. And so this is 6 times n times u, n is 6 here, so that is 6 times u. Second, x square del square u by del x square plus 2xy del square u del x del y plus y square del square u by del y square equal to n minus 1 into u. So this is 6 into 6 minus 1 into u. So that is nothing but 6 into 5. So that is 30 into u, 30 times u. Let us take one more example. If z equal to x power half plus y power half into x power n plus y power n, then find the value of x del z by del x plus y del z by del y. So here z, or you can say equal to fxy, is x power half plus y power half into x power n plus y power n. So now we take f of tx ty. So this is tx power half plus ty power half tx power n ty power n. So here we take outside t power half and here t power n. So here t power n plus half x power half plus y power half x power n plus y power n. And this is the f of x. So this is t power n plus half f of xy. So therefore, z or f of xy is a homogeneous function of degree n plus half. Degree n plus half. And therefore, by Euler's theorem, x times del z by del x plus y times del z by del y equal to n times z, but that n is degree of homogeneity. And here we have degree of homogeneity is n plus half. So that is n plus half times z. Next, if u equal to sine inverse x by y plus tan inverse y by x, then find the value of then prove that x times del u by del x plus y times del u by del y equal to x square del square u by del x square plus 2xy del square u by del x del y plus y square del square u by del y square. Okay. So let u equal to f of xy equal to sine inverse x by y plus tan inverse y by x. Now, first let us check for the homogeneous, whether this function is homogeneous or not. So f of tx dy equal to sine inverse tx by ty plus tan inverse ty by tx. This is equal to sine inverse x by y plus tan inverse y by x. And therefore you can say that f of tx dy, this is like equal to some t power 0 into this, that is f of xy. This is like t power 0, t outside nothing. So we can say t power 0. This is fxy. So therefore, u equal to fxy is a homogeneous function of degree 0 in x and y. And therefore, by Euler's theorem, x del u by del x plus y del u by del y equal to n times u. N is 0, 0 times u, and so that is 0. And x square del square u by del x square plus 2xy del square u del x del y plus y square del square u by del y square equal to n into n minus 1 into u So this is 0 into 0 minus 1 into u. So that is equal to 0. So right side here same. So left side also same. So therefore x del u by del x plus y del u by del y equal to 0 and 0 equal to this. X square del square u by del x square plus 2xy del square u del x del y plus y square del square u by del y square. We can take one more example. This theorem is true for 3 variables also. Okay, so if u equal to x by y power y by x, then find x del u by del x plus y del u by del y. Now let us quickly do this, because this you can easily prove that this is homogeneous function of degree 0. Prove this. It is not difficult, because tx by ty raised to ty by dx, tt cancel. So you will get same as like f of tx ty is tx by ty power ty by tx. Tt cancel. So you will have f of xy only. That is, you can consider t power 0 into f of xy. And so it is a homogeneous function of degree 0. And since it is homogeneous function of degree 0, you can say that x del u by del x plus y del u by del y is equal to 0 into u. So that is equal to 0. Okay, one more. If u equal to, it's the same, similar like this, e power x by y sine of x by y plus e power y by x cosine of x by y, prove that x del u by del x plus y del u by del y equal to 0. So here also you can see that u f of tx ty is like e power tx by ty, then sine of tx by ty plus e power ty by tx cosine tx by ty, and cancel out tt. And so this is f of xy, and so t power 0. So it is a homogeneous function of 0 degree. Okay, so you can say that therefore u equal to f of xy is a homogeneous function of degree 0, and therefore by Euler's theorem, x del u by del x plus y del u by del y equal to n times u, and so that is 0 times u, and so that is equal to 0. You can have one more. So like if u equal to 1 upon x square plus 1 over xy plus log x minus log y over x square. Then find the value of x del u by del x plus y del u by del y. So now here u is say f of xy equal to 1 upon x square plus 1 upon xy plus log x minus log y by x square. This can be written as log of x by y. And now f of tx ty is 1 upon t square x square plus 1 upon tx ty plus log of tx by ty over t square x square. And you can take 1 over t square, remaining is 1 over x square plus 1 over xy plus log of x by y over x square. And so this you can write as t power minus 2 f of xy. And therefore, u is a homogeneous function of degree minus 2. Therefore, by Euler's theorem, x times del u by del x plus y times del u by del y equal to n times u, and n is minus 2. So minus 2 times u. So next video we shall take some more corollaries and we shall solve some more examples. Thank you.